right, here we go. So let's try to remember that arc sine x has a range of negative pi over 2 to pi over 2. Arc cosine x has a range of 0 to pi. Arc tangent x has a range of negative pi over 2 to pi over 2. And the endpoints are not included on arc tangent x because that's where you have vertical asymptotes. Also remember that the domain, okay, that's the inside values, the domain of x is negative 1 to 1 on arc sine x and arc cosine x, because this will be important. Arc tangent x is all real numbers, okay? So example 5 says, if possible, find the exact value. I want the tangent of arc tangent of negative 5. So what I want you to do is I want you to turn back to that table we filled in just before this example. And if you look at the case of tangent, arc tangent x, x can be any real number. So then those cancel, and the answer is just negative 5. Okay, but you do have to check the criteria. So now for letter B, where I have arc sine of sine 5 pi over 3, look at that composition of functions chart. And if you look at the second half for sine, arc sine of sine y is equal to y only if y is between negative pi over 2 and pi over 2. Well, it's not. So my answer is not 5 pi over 3. However, we want to see if we can, in fact, figure it out. Well, I should know, what is the sine of 5 pi over 3? What quadrant is 5 pi over 3? Fourth. Reference angle's pi over 3, or 60 degrees. So it's negative radical 3 over 2. Okay? And something I found in the earlier class is we need to have our unit circle values down. Not that you're going and getting a unit circle out and looking at it. You need to really know them and be able to have quick recall. Because as we continue to move forward, we will be solving trig equations, and it's going to be a secondary skill to know these things. And if you're sitting there trying to figure that out, you're going to get really frustrated. So I would suggest that maybe you get some index cards and you put, like on the front, sine pi over 6, on the back 1/2. Another card, sine 2 pi over 3, on the back radical 3 over 2. On the front of another card, sine 7 pi over 6, on the back negative 1/2. And just keep practicing them because you need very quick recall. It'll just make life easier for you. All right, now, when I'm doing arc sine negative radical 3 over 2, I've got to remember the outputs are between negative pi over 2 and pi over 2. So I'm looking for what angle, when I take the sine of it, it's negative radical 3 over 2. Well, I know it's not positive in the first quadrant because this is negative radical 3 over 2. So I'm looking at a fourth quadrant, but a negative rotation from that x-axis. Does anybody know what's arc sine negative radical 3 over 2? Anybody? Good. Negative pi over 3. Do not give answers in degrees. It's okay if you're thinking of them in degrees, but inverse trig is traditionally done in radians. Okay, now let's look at this one. Okay, so I've got cosine of arc cosine. And if you look back at your composition of functions chart, this is the second row. And when you have cosine of arc cosine, x has to be a number between negative 1 and 1. What's wrong here? Pi is bigger than 1, isn't it? Because really, if you just look at this piece, this is saying the cosine of what angle is pi? And so here's where this piece was coming from up here. You can't get cosine of theta to spit out 3.14. It's only going to give you between negative 1 and 1. So this one is not defined. It's not possible to do. Okay? All right, example 6 says find the exact value. And I want to pause here a moment to make sure we understand and to clarify these instructions. Exact value means no decimal approximation. This means you're going to do it exactly, i.e. no calculator, okay? If you did something like arc cosine 2/3, your calculator will spit out a decimal, but it's going to go to the end of your screen and it's rounding it. A rounded answer is an approximation. It's not an exact value. So make sure you understand what it means by exact value. So if I want to find out the tangent of arc cosine 2/3, the inside, okay, arc cosine of 2/3, the answer is some angle. And another way to consider this is that the cosine of theta, that angle, is 2/3. I'm not even trying to do the tangent of it yet. I'm just trying to figure out this inside part. Well, arc cosine spits out values between 0 and pi. That's the first and the second quadrant. Well, because it's positive 2/3, it's in the first quadrant. So we're going to draw a triangle here in the first quadrant. SOHCAHTOA, cosine is adjacent over hypotenuse. So there's my 2 and my 3. We're going to use Pythagorean Theorem to figure out the missing side. What would it be? Square root 5, okay? This is square root 5. So now, remember, the answer is theta. Okay, whatever's coming out of here is theta. So I don't even know what the angle is. However, I can do the tangent of theta, can't I? It's TOA radical 5 over 2. Do you see that? I could actually compute this without even knowing what theta is. Okay? All right, now let's look at letter B. I want the cosine of arc sine of negative 3/5. So the answer to this inside is some angle. Arc sine negative 3/5 is some angle, theta. In other words, the sine of that angle equals 3/5. And here's where you guys, I don't know how you're going to keep it straight, but if you want to keep writing it down, like with every problem until you get it memorized, arc sine is spitting out angles between negative pi over 2 and pi over 2. That's first and fourth quadrant. So because this is sine theta equals a negative number, it's going to be down in the fourth quadrant. Sine is SOHCAHTOA. It's opposite over hypotenuse. So the 3 is the negative. Then this is a 3, 4, 5 right triangle. And then I want the cosine of that angle. So it's 4/5. And that makes sense, right? Because cosine is positive in the fourth quadrant. All students take calculus, okay? All right, now we're going to get a little bit more difficult. You guys okay on this up to this point? And don't worry, we're going to do a lot more practice. All right, let me slide it up so I have a little bit more room. All right, so now we're going to go more abstract. In example 7, it says, write each of the following as an algebraic expression in x. The sine of arc cosine of 3x. Well, I know the answer to the inside is an angle. So I'm going to say arc cosine of 3x equals theta, or cosine theta equals 3x. Now, if x is between 0 and 1/3, that's positive, right? If I'm plugging 0 to 1/3 in for that x, that's going to give me something positive. So I'm in the first quadrant. Here's theta. Cosine, remember from SOHCAHTOA, is adjacent over hypotenuse. Well, 3x is technically equal to 3x over 1. So here's my 3x, and there's my 1. Let's use Pythagorean Theorem to figure out what the missing side is. I'm going to do 3x, the quantity squared. Let's call it b. We'll call it b squared equals 1 squared. 9x squared plus b squared equals 1. B squared is 1 minus 9x squared. So that missing side is the square root of 1 minus 9x squared. Now we can compute the sine of theta. So katoa is the square root of 1 minus 9x squared. Now it's over 1, and then we're not typically going to leave it over 1. We'll just leave it like that. Let me pause here a moment to review an Algebra 2 idea. Can I simplify this as 1 minus 3x? Is that true? No. It's no, but let's make sure we understand why. If I had the square root of 16 minus 9, and you think that's 4 minus 3, it's clearly not, okay? So be careful. You may not simplify a square root of a sum or difference. You may, however, simplify a square root of a product. We do have that one. I just want to make sure we didn't make a silly algebra mistake in our future. All right, let's try one more. Here we go. So the answer to the inside is theta. So I'm going to start with arc cosine 3x equals theta, or cosine theta equals 3x. Now isn't that the exact same inside as we just did? So let's not redo the work, okay? So I've actually already got all the work here. Then to do cotangent is TOA being flipped. So that's 3x over the square root of 1 minus 9x squared. The good news is I am not going to ask you to rationalize that. Okay, I'm going to be happy, and I think you'll be happy if we can get to the point that we got to. But if you did rationalize it, let me just show you what that is. If you multiply the top and bottom by that radical, it would look like this. Just so that if you look in the back of the book and they happen to rationalize it, don't be alarmed. You know, you should be able to still see. You see, that's what it would look like. That's kind of yucky. So we'll be happy to get where we did.